I heartily welcome everyone in front of your screens to the very first NF Wire Forum event. We had planned for a physical event, but due to the current situation, we decided to at least kick it off with an online event as an introduction. So we are broadcasting live from here at Aurubis in Hamburg at our headquarters. My name is Tanja Winter, and I will be your host today, for which I'm very excited. In my usual life, I'm in charge for Aurubis Global Wire Rod Sales. Aurubis has partnered up with your trusted and leading suppliers, namely Balloffet for dies, NIEHOFF for wire drawing lines, BECHEM for lubricants, and the DKI, the German Institute for Copper, to form this consortium. As we would like to have this virtual event as interactive as possible, may I kindly ask you to take out your cell phones and open menti.com. Type in the code 9262153. And you can already see our first warm-up question. How are you feeling about today's event? Are you curious, excited, or rather neutral about it? I am indeed very excited and very curious. We will learn a lot about wire drawing today from our specialists. Maybe we can have a look already into the Menti results. There's not so many answers in yet, but they will come in, I'm sure. Currently, curious is heading, excited following. Maybe I start with being excited to welcome Harry here from BECHEM. Hello, Harry.
Hello, Tanja.
Welcome to Hamburg. It's such a pleasure to have you here. And since last year, we conducted the NE-FERROUS Forum in Germany, which is resulting from your previously bi-yearly event, the NE-UMFORM meeting. You can explain a bit about that, right?
A little bit, yes. Hello, everybody out on the screens. My name is Harry Hoffmann. I'm the sales manager of the metalworking division at BECHEM GmbH. Surely, like Tanja, most of you will ask yourself, what is it? What is the NF Wire Forum? It's an impressive name, isn't it? Yes, indeed, it is. This is surely a waste of time for me. No, we don't think so. We feel this is of quite high interest for you. Will there be any costs? Of course, yes. By registering, you signed in for a washing machine, a dishwasher, a stove. Everything will be delivered to you next week. No, of course, this was a joke. Don't worry. The only investment you have is to stay here, to listen to us, and to be interested. What could they teach me? I do not yet know. Yeah, stay curious. Let's see. But again, what is it? It is a platform. It is the platform for companies working in the wire producing industry.
But Harry, how did everything start back then?
Everything started in 1997 when BECHEM invited for the first wire drawing event in Germany. And you see here some pictures of this event. So this was the come together during the first evening, where we had a nice evening together with all these our friends. And the next day, we created presentation, or we had an agenda about presentation. And here we already received a strong support from NIEHOFF, from Balloffet, from DKI, and also from Aurubis, that time, Norddeutsche Affinerie. This event took place 11 times in a row, and somewhen it was very clear for all of us that we made it bigger, that we created the NE-FERROUS Forum, German for NF Wire Forum. So the first edition took place in November last year, and you see here the agenda which we had that time, and we made also a small video, which you can see here. Okay, and having this big success with the NE-Draht Forum, we decided now we do not stay in Germany, we go global. And here we are on the first NF Wire Forum.
Thank you very much, Harry, for these great and interesting insights. The event in Bad Sassendorf last November indeed was a great success. Now, what will be our special focus today?
Today we decided to focus on wire brakes, especially on cup and cone brakes.
Oh, very interesting and renowned topic. But before the 5 partners will each quickly introduce themselves to you, we would like to understand your background, so the audience outside on your screens. We are coming up with a second Mentimeter question about in which department are you working? We would be interested in that for sure. We have 5 different departments mentioned, from commercial, production, management, maintenance, and R&D. I indeed believe that this event is of interest for all these sections. What do you think, Harry?
Surely it is. I'm pretty sure for all these sections, for commercials, for production, for maintenance, for R&D, and also for the management. Surely also for the management, this is quite important. I personally think there will be most of the people participating from the production side.
Yeah, it's for sure a technically focused event. The one in Bad Sassendorf was mainly consisting of technical R&D, also management on the technical side primarily. But me being commercial, I can also assure that it's a very interesting format, and I'm glad being part of it. So far, we are seeing 17 people voting on Menti, so don't hesitate to still register. This is also free of charge. Just open it on your cell phone or another computer. Type in the code. There will be many more Mentimeter questions during the following presentations. And we will be glad to receive your feedback on that, because that's of the highest value for us. So if you're looking at the current results, there's quite management and commercial. It's even the front runners.
Not that many people from production. I'm a bit surprised.
Too. Yeah, maybe commercial and management is, they are more stuck to their IT tools, we don't know. But here, we see more coming in. Interesting few. Nobody from maintenance yet.
It sounds like the production has to produce.
Yeah, indeed. Good, so Harry, why don't we start with the introduction of BECHEM and learn a bit more about that fabulous company.
It's a pleasure for me. Just a few words about BECHEM. So BECHEM, the brand for specialty lubricants. So BECHEM was founded by Carl Bechem, and this is the reason for this name. So he founded this company in 1834, and this is the first oil-producing company in Germany. Nowadays, we are not in Germany anymore. Of course, we are, but we went global. And here you see the Bechem map, and we have quite some daughter companies, joint ventures, trading partners, technical partners all around the globe. We have different products in different areas, for example, for lubricating greases, lubricating oils, metal removal fluids, metal forming fluids, anti-friction coatings, and also corrosion preventives and chemical cleaners. We have 3 production sites in Germany, and then 1 in the US, 1 in China, and 1 in India. More or less 900 living products, actively sold products, not only spray cans like you see here, but drums would be too big to show it here on the screen, so therefore we decided to go for a can, but nevertheless we can supply all kind of packing. And we are supplying these products in different kind of industries. The automotive industry, the aircraft industry, the railways, mining industry, earth moving equipment, metal working, metal forming industry, food processing, wood processing industry, and so on and so on. So we are really the specialist for different kind of industries and different kind of application.
Thank you very much, Harry. Great insights into BECHEM and your products. Now I would like to welcome my colleague Cornel Abrates, who will give us a thorough view on Aurubis and what we do. Hello, Cornel. Thanks for being here.
Hello, Tanya. Thank you for your kind introduction. Dear ladies and gentlemen, my name is Cornel Abrates, and I'm in charge of technical marketing copper products, especially for copper rod and Aurubis rod, Rhine rod, and Fox rod at Aurubis. I have a metallurgical and metal forming background, and I coordinate the triangle consisting out of commercial production and customer production departments in case of product-related requests or concerns. Aurubis is the biggest copper refining and products producing company in Europe, and our strength is a production network of smelters, tank houses and rod lines in Europe. Aurubis strives for sustainability and close the loop along the entire supply chain of copper and other non-ferrous metals. The basis of our business are copper concentrates from mines and copper-containing scraps, intermediates out of different production steps and from end-user markets. We convert these pre-products in high-quality cathodes and copper products like copper rod, continuous cast billets and cakes, as well as flat-rolled products. In addition to that, with the acquisition of Metallo Group, there are 2 further sites in Belgium and Spain where we process complex recycling materials. Aurubis holds strong and leading market positions in cathode production output and respectively in copper wire rod output. Here you see figures from financial year 18-19 with around 1.1 million tons of cathodes and around 800,000 tons of wire rod. Beside that, Aurubis is a multi-metal refining company and produces metals like gold, silver, lead, tin and others. Aurubis has its own cathode basis, which is a fundamental position for our copper products and especially for copper wire rod, where 75% of all cathodes worldwide are consumed. Aurubis is independent from a cathode supply from South America or other regions, but can rely on own and very stable cathode supply. Aurubis rules a production network of 2 fully integrated plants with cathode and rod production in Hamburg, Germany, and in Belgium, in Olen. In Avellino, in the south of Italy, and in Emmerich, Germany, there are 2 standalone rod plants with cathode supplies from partly Pirdop, Bulgaria, and Lünen, Germany, as well as Olen, Belgium. Deutsche Gießdraht, the well-known copper wire rod producer of DG Rheinrod, located in Emmerich, is now 100% integrated in the production and service network of Aurubis Group. DG Rheinrod is a very well-known brand and stands for highest surface quality and drawability to thinnest wire diameters. The 4 rod lines are in excellent balanced production network to supply our customers in the EMEA region, from North Europe to South Africa, from Morocco to Egypt, with around 800,000 tons per year of Aurubis rod, Rheinrod. Responsible sourcing is becoming more and more important due to society requests. Therefore, the copper industry, and Aurubis as part of that, launched in March 2020 the Copper Mark as an industrial standard monitored and assessed by independent parties every 3 years. This goes hand in hand with the LME's responsible sourcing approach. At Aurubis, we like and support the idea that the copper value chain is mutually demonstrating responsibility to improve and develop, and we are looking forward to certified mines. Thank you for your attention, and I hand over back to Tanja.
Thank you very much, Cornel, for giving this great and thorough insight into Aurubis and our goals and setup.
It was a pleasure.
Much appreciated. Now, as our next guest, we welcome our partner, Michael Biller from company Balloffet. Welcome to Hamburg, Michael. Great to have you here.
Thanks very much, Tanja.
We look forward to hear about Balloffet now.
Okay, thank you very much. Thanks, Cornel, for your nice introduction and a nice welcome and bonjour from me from Balloffet. Thank you to everybody on your screen to join us on the first online event here in this branch. It's the first time that we made these, and be not so strong with us, okay? At first, my name is Michael Biller. I'm the sales manager from Balloffet. I'm for the market Austria, Germany, and also Liechtenstein. And I'm since 12 years on board on Balloffet. Balloffet is a family-owned company, and we are this year 150 years old. We are located in France, in Lyon, close to Lyon. And we are with 4 sister companies around the world and do also supply our service around the world. We are specialists in drawing dies and tools for the wire industry. We have our own R&D department to have permanent innovation and to optimize our products, and also especially for the non-ferrous industry. Our production is in France for dies and tools and all the wear parts. Everything is produced 100% in Europe, and this belongs to our best automatic process. Our product description for Balloffet is drawing dies from natural diamond and PCD, extrusion tools for the cable industry, also the compacting and stranding dies. Shaped dies is a very, very big growing market, also for the electric mobility. Enameling guides for the magnet wire, but also a big repolishing service for all used dies. We are also specialists in training and analyzing on the die repair of all people working in this field, and we are producing equipment for the die shop. Thank you.
Thank you very much, Michael. Good
Thanks
introduction of Balloffet. And we are now looking forward to welcoming Stefan Gorgels here from NIEHOFF, from the famous town of Schwabach in further south Germany. Hi, Stefan. Good to have you here. And I'm looking forward to your introduction of NIEHOFF.
Yeah, thank you very much. Okay, also a warm welcome from my side. My name is Stefan Gorgels. I work as sales manager for NIEHOFF company, and I would like to introduce my company. So, NIEHOFF company was founded in 1951, but the origins or roots go back to 1859. But listing all these historical details would be too long. However, the new construction of the factory, which was completed in 2015, should be emphasized. Locations worldwide. The headquarter and main factory is in Schwabach. It's factory number 1. Factory number 2 is in Marktoberdorf, Leuterschacht. Factory number 3 is NIEHOFF of Czech Republic in Limburg. We also have factories for the local market in the United States, Swedesboro, Brazil, Sao Paulo, India, Hyderabad, and China, Shanghai. HFSIB in Sweden, Montana, is a factory for lead extruders. Sales and service centers we have in Spain, Barcelona, in Moscow, in Tokyo, and Singapore. The number of employees in Germany and worldwide. Germany, we have 461, and 10% of these employees, exactly 50, are trainees. Worldwide, we have 920. Our products. Since 1951, NIEHOFF produced 930 rod breakdown machines, nearly 1,500 multi-wire machines. We produced 4,500 bunching machines with a bobbin size from 400 up to 2,000 millimeters. Braiders, NPS spoolers, stranding machine for insulated wires, also with a bobbin size from 400 up to 2,000 millimeters. Galvanic plating lines, and last but not least, inductive annealers. Mobility, urbanization, energy distribution, digitalization, power generation. These are the challenges of today and tomorrow. And how to face these challenges? We are partnering with expertise, high cost efficiency, high flexibility, reliable service worldwide. These are the demands on us and how our customers see us. Thank you very much.
Thank you very much, Stefan.
Okay.
Good introduction of an amazing company, and thanks for coming to Hamburg.
Okay, thank you very much.
Now, last but not least, I'm pleased to welcome Michael Sander to Hamburg, the Managing Director of the DKI, the Deutsche Kupferinstitut, so the German Association for the Copper Industry. Welcome to Hamburg, Michael.
Thank you, Tanja. Ladies and gentlemen, before I will start with the actual topic of our event, I would like to introduce you to the work of the Deutsches Kupferinstitut, German Copper Institute. As an independent technical and scientific association, the Institute has been providing knowledge transfer around the material copper since 1927. We are promoting the acceptance, production, and use of the copper-containing products in the interests of our members of the copper processing industry. As an association with a high reputation, the Institute represents the interest of its member companies in internal and international bodies and committees. In addition to our events, projects, and communication platforms, we are giving access to copper know-how and research. As a neutral expert team, we are able to provide tailor-made solutions by analyzing, processing, and application forms of copper and copper alloys, and thus for the support and benefit of your company and your customers. We offer our members also direct and timely access to information concerning the developing regulatory situation at European and national level regarding the copper issues. The German Copper Institute is a national and international point of contact for consultancy around copper. Besides the possibility of exchanging information with the other members and the association in industry research and specialist committees, the working groups, we also offer open and in-house seminars. Also, we are providing engineering services for non-members, such as material analysis using spark spectrometry, oxygen determination, and hardness measurement, as well as fracture analysis using light microscopes and scanning electron microscopy with EDX. We are happy to support you in all your challenges. Before my colleagues go into the individual system elements of the drawing process in the following lectures, I would like to give you a brief overview of the influencing factors which are relevant for the drawing process and wire breaks. But first, I would like to ask you to answer the following questions via Mentimeter. In your opinion, which elements are most important for a successful drawing process? Please choose and add one after the other with a plus symbol. First, the most important, last, the least important. The die sets, the drawing lubricant, drawing machines, the people in the production process, or the wire material. Please vote now. We will have a look at the results later. When looking at the drawing process, it seems at first glance to be a fairly simple system with 4 main elements. In practice, however, the interlinking of several processes and large number of drawing steps results to a complex system in which the causes of errors are not immediately recognizable, and the interaction of many individual influencing factors has an impact on quality and process stability. Last but not least, the conception, selection, maintenance, and settings of the system elements are based on the decisions and assessments of the people involved in the process. Knowing about the process and the elements is therefore essential to achieve good results. In the following, we will now use the cup and cone breaks as an example to explain the influence of the individual system elements. Wire material, drawing die, drawing medium, and drawing machine on the drawing process. Let's have a look on the Mentimeter again about the results of our first question. Oh, it's a surprise for me. Wire material comes on first side, second is the die sets, and then the drawing lubricant. I didn't expect that the way, but maybe we can discuss this later. And now I'm looking forward to Dr. Abrates from Aurubis AG, who will first give us an overview of the wire rod production process. Please, Dr. Abrates.
Thank you, Michael, from DKI, for your kind introduction into the topic of wire drawing and its influencing factors. First of all, I would like as well to remind you to vote for the next Mentimeter question about wire break types. I'm very pleased to speak about the copper wire rod process, about Aurubis rod, Rhine rod, as one factor to conduct successfully wire drawing processes. What can Aurubis do to avoid wire breaks? There are 5 main process steps influencing the quality of copper wire rod. First, the feed mix. The best feed mix of grade A cathodes to achieve copper quality which is needed to draw down to different wire diameters. Second, melting of the feed mix. A constant metal flow with the right temperature and gas level to supply the rod line with the needed volume flow rate. Third, casting and solidification. Main area of interest to produce rod with outstanding drawing properties. Homogeneous heat transfer, degassing, and constant growth of solid copper. Fourth, the rolling and surface treatment. Reduction of the cross-section to gain mechanical properties to process the wire rod in cold drawing down to 0.1 millimeter or lower and exclude iron inclusions. Fifth, the quality control, control of the product, the parameter sets of the line, and the required physical, chemical, and mechanical properties. Please see here criteria which are important and are the basis for a successful drawing process of Aurubis rod, Ryan rod. So as mentioned before, best feed mix with grade A cathodes, oxygen content below 250, a delta temperature of copper melt versus copper solid temperature, cooling water, min-max values, rolling current at the rolling stands as well in min and max values, low defectomat and ferromat signals, good twist test results, and last but not least, low residual oxide layer. But unfortunately, there are incidences resulting in wire breaks, which leads to downtimes in your production departments. Important is to understand what kind of wire break type the sample shows and what leads to the different wire break types. All in all, a wire break is the unfavorable result of interactions between the wire material, drawing dies, emulsion, and the machines, as well as drawing process parameters. In general, there are well-known wire break types, which occur from time to time in each and every wire production facility. There are three main types, which are cup and cone, first, second, ductile force break, third, inclusion break. The other mentioned types are as well known and present, but with less frequency to our experience. Let's look to the features of a wire break, so-called cup and cone. What is important? So you see on this side here a deep hole in the cup side, a cavity in the middle of the wire, and a cone, which is here. You see a necking tip. You see surface defects, what you see here on this photo. And when you do a metallurgical cross-section, a longitudinal one, then you see the so-called craw feeds in the longitudinal cross-section. So no impurities, no phase agglomerations in the copper wire matrix. What are the damage mechanisms? So high shear stresses between wire surface and the neutral line induces local failures where the max material stress level is exceeded. Then the inner cracks, the craw feeds, are beginning. The tip of the craw feed is orientated in drawing direction. With additional strain, these cracks grow and reduce the load-bearing cross-section of the wire until the material fails or break. As well, the copper wire rod can influence cup and cone breaks, but that is the reason mentioned at the beginning of my presentation to rule and apply the appropriate production criteria to avoid cup and cone breaks. Now let's have a look on the Mentimeter results. What you vote, what is your favorite wire break, what you see in your productions. I'm not surprised, cup and cone and inclusion breaks. That fits to my expectations. So, thank you very much, and now I will hand over to my colleague Michael from Balloffet. Thank you very much.
Thank you, Cornel, and hello again from my side, and hello again to my short presentation here on this online event. But before I start with my presentation, I want to invite you to the Mentimeter question as well, and these belonging to the question on dies. What is for you important on dies? I invite you to vote, and we will see the result later on. Wire breakage is not really nice. Nobody wants to have these because wire breaks is normally less productivity. We lose a lot of material. It is inefficient, But the question from my side and from the Balloffet side is, what can Balloffet do to reduce wire breaks? The wire breaks, the view from the die producer is as follows. We have to check if the customer has used the wrong diameter, or the geometry is not respected, the polishing is too rough, the dies are not cleaned, we have a mishandling on dies, we have imperfect technical matchings, so the specification from the drawing machine is not corresponding to the die sequence. The dies are fixed on the wrong position. The elongation problems and the slip is not suitable. We have a lack of maintenance, die maintenance. We have a lot of die wear. We have deep drawing rings, or we have irregular die wear. This is mostly a problem of wire breakage. At first, we have a checklist, and our technical checklist from Balloffet is to check all the parameters to reduce and to find the result. The root cause is, at first, we have to check the machine parameter and the machine specification, and to clear if the machine parameter is fitting to this die sequence. This is what we have to control, and you see these here in these tableaux that you can check if this is correct. The next step on the checklist is the check of the elongation. Is the elongation respected? What we have here and what we see here, and what is later on the possible action by us to control if the difference between the die elongation and the machine elongation is be checked. On the dies, we have also many issues to control. The diameter at first, but also the not fitting geometry. We have to check the polishing, and we have also to check if we have used the probably wrong tolerances. For these, we have a special specification where we see in the die if the blending is well made, and if we have on a multi-line machine tight tolerances, use tight tolerances, because we have to check that we time to time have 500 dies on the machine, and these has to be fit. The die analysis is also checked the issues in the die. Is the die size with the adapted tolerances produced? Is the die geometry respected? The die blending, so it means from the angle to the bearing length, is this well polished? Is this not too sharp? And this is a mirror polishing is made. And also the exit is very important, because if we produce in the wire process some fines, then we produce the fines on the exit of the die. So it has to be nice rounded. And what is very important on a die set, that all the same sizes on the same position on the machine has to be respected. And this means not for one set, for all sets, and in total probably 500. Coming back to the next check, what we have to do is the lubricants, because we have to secure that the die is very clean and very regularly cleaned with a spray of lubricants during the process. Because if you see some fines in the die, it is coming from the die before, and the result is seen on the next coming die. The lack of not perfect filtration and die cleaning means this limits as much as possible the quantity of metal fines. That means reduce the metal fines and clean the dies during the process. And this has to be made by a jet of lubricants during the drawing process. And also, the extreme drawing parameters, because we're using high speed, we have ultra-fine wires, we have a reduced slip. That means our dies has to be perfect, absolutely perfect. We have to check if there is a drawing ring inside, because in a drawing ring we are sticking material, and we take these material into the next die and we create problems. And if we have these problems, we create thermal shocks, and the thermal shock means we can produce a diamond pull-out or a breakage of the die. We have to check also the impact point, and if we take out a used and a worn die out of the machine, we can read in a die like in a book. If you have further questions, please send us an email, check our webpage, and thanks for your attention. But before saying bye-bye, we're going back to our Mentimeter questions and see the result. And the result is really, really interesting. You have 6 possible choices to make. And here we see, and this is not surprising for me, at number 1 is the die geometry. It is absolutely important to check and to have the right geometry on the machine. Thank you very much for your attention. Thank you to listen to my short presentation. A warm welcome now to Christopher from BECHEM. Thank you very much.
So I would also like to welcome everyone to this event. At the beginning, please also, as the previous colleagues already told you, look at the Mentimeter. There's a new question and answer it quietly. So I would like to introduce myself first, as I was not aware by now. My name is Christopher Volland, and I'm the technical manager for wire drawing within the BECHEM company. And I would like to look with you into the field of the lubricant in relation with cap and comb brakes. Honestly, in general, the lubricant is not directly the first thing to point on if you have a cap and comb brake. Nevertheless, it can be a cause for a cap and comb brake if there were failures in the previous drawing steps. So especially in the rod breakdown. I will explain this in the previous slides. But as Michael already said, also a lack in lubricity due to lubricity failures because of dirty dies or missing lubricant are points to get a cap and comb brake due to lubricity. So if we look at the rod breakdown, you can drive it with different drawing options. Typically, it is driven with a concentration of 12 to 18%, but it is also possible to drive it with 5 to 8. But what is the result of this different drawing option? First of all, let us take a quick look on saving calculation for the lower drawing concentration. Let us estimate a system with 10 cubic meters and a price of €5 per kilogram for the lubricant. So if we drive it with 15%, we would need 1,500 kilograms of lubricant and would rise to a price of €7,500 for the filling. If we do the same with the 5% concentration, we have 500 kilograms and €2,500, which gives you a saving of €5,000 estimated. Plus maybe another €5,000 over the top-up time for 1 year driving. Would be €10,000 in total. But what does this mean for the drawing process itself? First of all, your rod breakdown system maybe has to be driven a little bit slower. Normally 25 to 30 meters are possible. Now you can only drive 20 meters, for example. So you have a reduced production capacity. Secondly, you get small damages to your rod wire. These small damages will give you bigger, not bigger, but the damage size stays same and the diameter size gets lower. So the damage area gets bigger in relation to the total diameter, and by this a break can occur over the time. So this is where you can see that the pre-damaging in the rod breakdown can cause breaks in the multi-wire or even in the finest wire steps. This enhanced breaks in the multi-wire and fine drawing section will cause machine downtime and scrap production. If you estimate the costs for this machine downtime and the scrap production for a 24-wire machine, for example, which has a capital break of every 24 wires, you can estimate what huge costs this will produce. And I would estimate that the costs for this downtimes are higher than the costs for the higher driving concentration. Nevertheless, besides the driving concentration, you should also look on the other parameters of the emulsion. The emulsion is not only the concentration, it's also the pH value, which gives you an indicator for microbiological impact, for example, and all the other figures which can be analyzed by the lubricant producer, so for example by us. And we are always warmly welcoming you, if you have a question, to come to us and ask us. And now let us please have a look on the Mentimeter results and see what is the main point to look on. And I'm glad to see that you are thinking the same as I do. The maintenance and care is absolutely essential. Thank you for your time, and I would like to give over to Stefan from NIEHOFF for some in-views on the machine side.
Yeah, here we are back again. Christopher, thank you very much. So, the first comment from my side is a reminder. Please answer the Mentimeter questions. Wire breaks are inevitable when drawing wire. That means machine downtime, loss of production, and re-thread up of wire in the drawing machine and annealer. To avoid or eliminate these wire breaks, knowledge of their causes and mechanism of creation is necessary. Okay, we know many types of wire breaks, but let's concentrate on two cup and cone break. This is a working principle of a drawing machine. The wire gets compressed in the die, and the diameter decreases, the length of the speed increases. Here we need lubrication to lubricate or cool the process. Without or with too little of lubricate, the drawing die and the wire will be destroyed. Surface roughness, wrong angle, wrong diameter, a wire break is inevitable. A broken wire based on this normally is a cup and cone break. The wire is compressed in the die. We learned we have elongation between 55 and 26% for a rod breakdown process, and between 26 and 10% in a multi-wire or fine wire machine. For this process to work properly, everything has to be perfect. For this process to work properly, everything has to be perfect, we said. But now let's see possible cases for the cup and cone break. There can be a combination of large cross-section area reduction and large deformation angles in the die. That's called a die wear. Too strong cross-section area reduction or lack of lubrication. In case of high friction in the die, wrong geometry or too strong cross-section area reduction, the outer skin of the wire is held back. The center of the wire moves and it comes to cracks in the interior. So here, Possible cases for a wire break: a cup and cone break normally is caused in the die. Here we see a damaged die. The next page, the next picture shows a emulsion circulation system in the drawing die holder, how it should be. Emulsion float, how it should be. But if the die holder is dry, then it's creating problems. If you don't clean the lubrication system regularly, the flow channel can become clogged with deposit or with copper flakes. No lubrication comes to the die, a wire break is inevitable. So, something to the wire break. The cone tip of the break always shows in the direction of the drawing. But notice, if in a wire drawing machine or multi-wire machine, the cone tip shows against the drawing direction, then it's a clear indicator that the error cause originated in the rod breakdown machine. Some requirements for trouble-free operation. The first thing I want to mention is the qualification of the operator. This requires the next points: careful handling of the machine, regular inspection of wire, drawing dies, emulsion, drawing cones, the filtration system, regular cleaning of the machine. On the left side, we can see a bad cone that needed to be replaced. On the good side, on the right side, a good cone for optimal results. Here are some examples how it shouldn't be. The last example doesn't cause a cup and cone break, it causes a tensile break. And this is a tensile break, not a cup and cone. And here we are at the end of my presentation. So if you have questions, don't hesitate to send me an email. I will try to answer them. Now, let's have a look to the Mentimeter results. Yeah, it looks very good. Okay, I think these are the results I expected to, but we can discuss it later on. Thank you very much for your Mentimeter results. So I will give back to Tanja, and thank you very much for your kind attention.
Thank you very much, Stefan, and also to all the other gentlemen who gave such great insights into their profession. Before we take a short break to reconstruct our setting here in Hamburg in order to prepare the panel discussion, let's have a look into the Menti results of the question asked by Michael Sander. We're almost there. Yeah, here we are. So, the ranking has come out to be, first, the wire material is the most crucial aspect. Second, the die sets. And third, the drawing machines. We will take that up for our panel discussion, as just mentioned. And we would also like you, or encourage you, to ask to take the question section of the Mentimeter and post your questions that you have for our specialists in there. Stay tuned, we will be back shortly. Welcome back to start our panel discussion with all 5 partners right now, here live on the stage. So, what do you think about this result? Is it as expected? Cornel, please comment on being the first in that ranking, the wire material.
Yeah, I'm not surprised about your answers and your votes. About the wire material. It is important, as shown in my presentation, but it's only one component in the system of what we have. So of the machine, of the dies, of the lubrication. So everything counts, and the rod is one part of it.
Thank you, Cornel. I believe the second one was the die set. Michael Biller, what do you think about that?
It's nice to see from our side that die sets has this big meaning in the process, but as Cornel said, it is really one of the parts for optimized production. We need a good machine, we need good pre-material, we need also good knowledge of the worker on the machine. Die set is important, but also the lubricants, we can't forget. And everything and all the things are working together. We can't take one as the main part. It's a combination of all 5 things. Thank you.
And indeed, of course, all the 5 dimensions, let's say, got votes. But the third in the ranking was the wire machine. So Stefan, what do you think about that?
Yeah, I think the machine is very important, but as important is the operator, because the operator has everything in his hand. His knowledge is very important, and he can see when something is going wrong at the die, at the machine, at the lubrication. When he don't have this knowledge to see what is going wrong, then we have big problems, and these problems normally will end in wire break. So the operator is the key person for it.
Thank you, Stefan. I think we are all surprised that the operator, I believe, came even in last. But what do you think does the machine operator have to do in order to avoid cup and cone breaks? Michael Biller.
The operator is one of the main person in this process. He has to check the machine frequently. He has to check the dies, he has to check the lubricants, he has to check the machine, he has to listen to all the points during the process, and this is important. This is the main person in this process.
Michael, I'm absolutely with you in this point. The machine operator is absolutely responsible for a good drawing result, because he sees the machine every day. He can look at the filtration, he can look at how does my cones and my dies look. Is the lubricant working well? Is the lubricity wetting well? So if he doesn't look properly, we will see problems in the machine, in the drawing process especially.
Yeah, Christopher, you are right, but that means a regular inspection of the wire, of the dies, of the lubrication, of all parts of the machine. He has to check it daily, or some parts once a week, depends on how the machine is doing and how fast the machine is running and so on. He has to look with his eyes.
I'm definitely with you.
Yeah. But he has also to clean. This is also important to have a really clean process, okay? It is also necessary to clean the lubricants, to have clean dies, okay? You can't clean the dies, it is perfect, but if the lubricant is not so cleaned, you create problems.
Of course.
So we need a proper filtration.
Yeah, right.
Stefan, a question for you mainly, I think. How does the drawing machine cause a cup and cone break?
Okay, the drawing machine themselves can't create a cup and cone break directly. The tools can do it. A cup and cone break normally is created in a drawing die. The causes are lack of coolant or wrong coolant lubrication, the wrong temperature of the lubrication, wrong drawing dies, sorry, or the wrong diameter, wrong angle in the drawing dies, or a damaged drawing die. These can create a cup and cone break.
Yes, as we have seen in the Mentimeter question, the cup and cone break is coming from the tools, you are right. But the question is, and the thing is, that the geometry is one of the main part in the dies. If we don't respect the geometry and the polishing or the incorrect use of the dies, we create these problems. We create these. Especially if the lubricity, as you already said, is lacking, we will see problems. And this can be caused
by a too low concentration,
Yeah.
a too low pH also, because if the pH level doesn't fit, the properties of the lubricant won't fit. And definitely, if there are lubricity lags due to a wrong flow rate or a wrong temperature performance, we will see problems. And the wrong temperature performance can maybe be caused due to biofilms in the cooling system, for example.
Cup and cone breaks are initiated, for example, due to missing emulsion in a single die, as we've heard. How can this phenomena 100% be avoided and controlled? Are there any means or measures to be implemented? Christopher.
So in general, you can't 100% avoid this problem. Because if something went wrong in the system, maybe a sealing broke down or something like that, there can be particles in the lubrication system which can block a spraying nose. And then we will get problems with the spraying at one position, for example. But anyway, by frequently looking at the spraying system that everything is free and working well, and looking on the right process pressure of the emulsion and flow rate, this helps a lot. Nevertheless, the right wetting properties of the emulsions are very sufficient. And a clean emulsion, so a proper filtration. And this has to be checked regularly by simply looking on the filtration by the operator if we have nice white edges, because this is showing us that the filtration is sealed properly.
Yes, I agree. An efficient filter system helps to keep dirt and copper particles out of the lubricant, and this is very important.
Definitely, yeah.
Yeah, and there are a lot of components, let me say, in the machine maintaining emulsion in each die. There are, let me say, no sensors or in the die to control the flow. So therefore, the machine maintenance is the key, and the operators need to know what to do, and they need to know their machine, for sure.
Yeah, that's right. But notice we have no automatic control of each drawing die. We can control the pressure of the lubricant and the temperature and the flow, but we can't control each drawing die during the process. This can only be done by the operator. We always speak about the operator. The operator has to control the machine. He has to control the flow channels, everything of the lubrication system, that it's clean and that lubrication is coming out of the holes of this system. That's very important.
But it's also important not to create any fines. And
Exactly,
these belongs to the die producer. So we have to respect all the geometry. We have to respect what I said in my presentation. We have to respect the back relief. We have to have a smooth exit on the die, that because the fines we are producing on the exit of the die. And this is what we, as the view from the die producer, we have to respect these and we have to follow these.
Yeah, you have seen the picture of the drawing die holder, and we have float channels at the back and the front of the die, and to remove these dust.
These helps a lot. These helps a lot. These helps a lot.
Definitely.
Yeah.
Also, a lubrication of the cone is necessary, because otherwise there also some fines can be created of wire which is scrapping on each other due to the slingings.
Yeah.
Gentlemen, I do like this active discussion. Thank you very much for that. This is great to see and hear. I have a question here from the audience. And I believe it's a good one for Cornel. How does the chemical composition influence the resistance of the copper?
Easy to answer. The higher the purity of the copper, the higher the resistance in the end. This is what we know over the years. If we increase the impurity level, we will go down with conductivity and see higher resistivity. So this is the key. So the right feed mix is very, very important.
Thank you. And another one I would ask that firstly, at least to Stefan. How does annealing of semi-finished product affect the final wire?
Yeah, you know, during the drawing process, the copper gets hard. But normally, we need soft copper for most applications. That means we need an annealer, yeah, to get the copper back to soft copper. And this annealer, which is working with electrician power and with contact pulleys, also can create problems, of course, if you use this annealer not in the right way. And an annealer, of course, it is placed in nearly each drawing machine, multi-wire machine or fine wire machine, not in each rod breakdown machine, because if we put this wire later on in a multi-wire machine, it can be hard. But for a final process, we need an annealer, yes, of course. And this annealer must be handled very careful, like the drawing machine, so that you can't create problems with the annealer.
Stefan, in my opinion, the question of an annealing of the rod system is a little bit depending on how is the further production going on. If you have long ways for the copper to be fed into the machine, a soft wire is definitely better, as I have seen in the practice, because otherwise you are carrying a lot of fines into the machine by the long distance of the copper, yeah, which is going over several wheels for the weight changing points.
That's correct. I agree with you. Depends on the wire, the finished wire I need. Yeah. If I want to have a very small diameter, very small cross section, 0.05 square millimeters, for example, then it's necessary to use annealed copper. Yeah. Yeah. But if we only need 0.3 or 0.5 millimeters as a finished product, yeah, then you can go with hard copper into the multi-wire machine. I agree with you, absolutely.
And it depends a little bit as well on the application. If you go more in the, let me say, energy cable application, or if you go more in the, let me say, magnet wire sections, I think you have to distinguish as well what is my final application and the requirements of my customers.
Exactly. Or the next process step.
Or the next, yeah, for sure, yes. Yeah.
Thank you very much. Lively discussion again. There's another question from the audience for Michael Biller. What die angle do you recommend for ETP copper?
For ATP copper, it's normally 18 degrees, what we recommend. But it's over the question of diameter, what we are using. So if we have a bigger diameter, it could be a bit wider open angle, but in general, it's 18, 19 degrees, what we recommend.
Thank you, Michael. We have heard quite a bit already about the topic of maintenance as well. So what are typical maintenance needs for the drawing process? Copper, machine, dies, lubricant, to have the best success?
I start with, let me say, copper rod, because this is a pre-material, which is important, which, let me say, is in the end, the material which breaks. So it is important that the copper wire rod is produced as presented some minutes before in my presentation. So this is important to look on the selected criteria shown in my presentation. But I think there is more than only the wire rod.
Yeah. I think it's important to define the correct cycles of inspection, replacement, or maintenance for all systems, all system elements at all levels in order to ensure the process stability.
Yeah, I think it's advisable to clean the machine once a week and to check everything, the drawing dies, the lubrication, the emulsion, the drawing cones, the contact pulleys, the filtration system, to check everything and to clean everything. And to do it once a week, maybe on Friday on the last shift, you need half a shift, 4 hours for it. I think these 4 hours are well investigated. This is very important to take these 4 hours once a week.
Plus a few minutes, a few times a week to check the concentration and the pH level of the lubricant.
So it also comes to the situation that the man on the machine is one of the important persons, okay?
Definitely.
He has to check all the parameters. He has to check the machine, he has to check the lubricants, he has also to check the raw material, and finally he has to check the dyes in his machine. This is what he has to do. He has to listen to his machine because the machine tells him a lot if he listens carefully to his process. And the machine gives him some information what is wrong and what is not wrong, okay? But to let the machine run without inspection creates problems.
Yeah. But anyway, definitely, my opinion is if there is one guy who is responsible for the lubricant of all machines, often it's better than every machine has a own guy who is thinking of, oh, I put in some defoamer, I put in this or that. Because this creates trouble, because there are no notes then, and nobody can tell you in the afterwards what has been put in. And you are looking for a problem cause which is there maybe by a mishandling.
And finally, 6 machines could be 6 different materials and 6 different processes, so 6 different results. This is what has to be checked.
Yeah, but one thing is clear, the machine speaks. But the operator must understand the language of the machine.
He has to listen. He has to listen.
That's the problem, yeah? He must be well trained so that he knows what the machine will tell him. What is wrong? What's going wrong?
So if there are new guys, a proper training is definitely essential. And maybe a proper training by someone who's from the different fields also. So the request to one of us would be not too bad at that point.
And this describes the situation actually now. What we have in 2, 3, 5 years with sensors everywhere, we don't know. But actually, we have to handle the problems, okay?
Maybe then we will have self-lubricating dyes, I don't know.
We don't know.
A sensor can't be so good as a feeling of an operator.
And at least the most dangerous thing is the unexpected. And only the operator who's close to the process can see the unexpected things.
Yeah, this is, of course, a great offer from the NF Wire Forum. Don't hesitate to get in touch with any and all of us. There's also another question from the audience that just popped in, and that's one for Christopher. Is it possible that a bad temperature of lubricant break the wire in the drawing process? What is the optimal temperature?
So it is not directly possible that the wrong temperature of the lubricant will break the wire. But the wrong temperature of the lubricant can cause incidental wire breaks because of a bad cooling of the dyes, for example, or a bad wetting ability. For our products, we recommend a temperature between 35 and 45 degrees Celsius as a rough range. And as fine range, we recommend 38 to 42 degrees Celsius. Because in this temperature range, we have the optimal mixture of lubricity, wetting properties, and lifetime of the emulsion. If you go too high with the temperature, you will get better wetting, but less lubricity because of a thinner lubricant film. And also, you reduce the lifespan of the emulsion because the aging of the emulsion is faster than.
Yeah, I think a drawing machine is the same like a motor. If a motor is cold, you can't run him with full speed. It's the same with a drawing machine. If the drawing machine is cold, if you start the machine on Monday morning, you have to go very slow. Don't go directly onto 30 meters per second. Then you will create a wire break. Go very slow, step by step. You can increase the speed and look to the temperature. If the temperature is cold, less than 30 degrees, then you have no chance to run the machine with a normal speed.
Absolutely. And also, after the fresh setup, you need to run it up slowly to get in the right temperature range and to get a well mixture of everything. Because if you mix up 10 cubic meters, they won't be mixed completely in 20 seconds. You need a few hours until everything is mixed well through. through all the pipings and everything.
But temperature is the main subject, because if we have a block on the lubricant, so if we are sticking some fines in the die, we are not cooling the die. So we create by 30 meters per second, what you said, Stefan, it's very, very difficult, and we have to understand how many meters are running in 1 or 2 minutes through the die. And the temperature is growing from 60 to 100 to 200 degrees, even more. Yeah. And the diamond inside, he can take a lot of, he's very resist, no problem. But the only thing a diamond is not willing to follow is the temperature change. So if we cool then, when the big block is going out of the die, and we cool again the die, we have a temperature shock, and this is what we see, that is a thermal shock. We have a horizontal break into the diamond, and the diamond is gone. This is the worst we can have.
That means you can create a break in the die with a low temperature and a high speed.
Yeah.
Okay.
No, not directly.
Not change. Yeah. It is the change from the high temperature to the low temperature, okay. In between from 1 second to another. Okay. And this creates the break.
Okay.
Especially as the formation temperatures which we are raising are point temperatures of 200 degrees Celsius without any problems between the copper and the die. This was measured as near as possible.
Yeah.
This is such a great discussion, gentlemen, really. I would love to continue listening to you forever, pretty much, but we are coming to the last question because time is passing by so quickly. And it's a question from the audience, which I find very interesting. What is the biggest step forward or innovation in the last 5 years in general wire drawing?
Yeah, I think to build machines with individual drives is a big step. In the past, we had gear machines, and today we have rod breakdown machines with individual drives and multi-wire machine with block drives. That means 6 or 7 capstans or drawing cones with one motor, so that you have, for example, 21 draft machine with 5 motors, or 31 draft machine with 7 motors. This is innovation, I think.
Yeah, definitely. And this has one big benefit, especially in the rod breakdown. We can't have gear oil leakages into the emulsion or the other way around, which can cause major breakdowns in the machine. Because if there is emulsion rinsing into the gear oil system, you can quickly face corrosion problems, and by that, a major break of the gear system.
Yeah, what is also important from the view of the die maker is that we have more and more integrated automatic processes to produce the die, the same die like the other die. This is the main subject, and we can now better control the dies with the better measurement system to have always the right product. This is a big step forward.
Michael, in my opinion, also the finer particle sizes in the PCB dies are a big benefit, as a smaller breakout of a particle causes less problems. If we look 10 years back or something like that, with bigger particle sizes, we had breaks which caused directly hard scraps in the wire.
Absolutely, absolutely.
And from copper wire rod, I would say in the last year we make the separation and selection criteria more to the application. So if we know a customer needs copper wire rod for 50 microns, of course we apply our selection criteria in that way that it's really possible that our customer can draw the wire into these diameter ranges.
Okay.
Good. This was a great conclusion of the panel, I would say, and we will now take really a very, very short break until we come to the final of today's event. So we will be back in very, very short time. Please stay tuned. This was a very interesting and lively discussion. Time went by so quickly, and we are already approaching the end of our event. Harry, what do you think? What is your main takeaway of today?
Yeah, it is obvious that smoothest wire drawing depends on multiple influencing factors. Of course, the rod quality, the drawing equipment, the die setup, the drawing lubricant, including filtration. But I was deeply impressed about the discussion of the last 20 minutes where all our friends mentioned the operator. He is the responsible one. He is the key factor. And surely he is. He is not the only one, but one of the key factors. And wire drawing companies should focus more on the skills and the education and the know-how of the operator.
Yeah, thank you. So that's pretty much the wish of the NF Wire Forum Consortium to its customers and partners in the market, right? Mm-hmm. Somehow.
That's
Make sure your staff is trained very well. Now, the very last Menti question for today, I would like to encourage everyone online to take part in that. Which topics would be of highest interest to you for the future, for any of our future events that we are planning? It is, of course, crucial for us that we plan it in accordance with your interests. So please shoot it in. It's a very open question, can be answered only with one word or several one-word answers, and it will be building a cloud. So while the cloud is building up, I would like to invite you for a hopefully possible physical event in Antwerp, which we will conduct, or so far are planning at least to conduct, in March. During that occasion, we will also invite our customers to a planned tour to Aurubis in Olen.
Establishing the NF Wire Forum definitely was a perfect decision. We heard interesting presentation. We received a lot of very precise questions, followed by a very open and intensive chat here on the stage. So it is obvious that this event was a success, and we definitely will continue with it, hopefully in Antwerp, hopefully springtime next year.
Yeah, this would be great. But if the current corona situation doesn't allow, we will find any other way. And of course, we're always in touch with you, our customers, partners, and we'll be glad if we receive any feedback from your side. Speaking of feedback, maybe another look onto the Mentimeter cloud. So what do we see here? Emulsion systems, dyes, lubrication, problem solving. So we keep this open, of course, for a little longer so that each one of you on the screens can think about it. And yeah, please give us your insights or your requests, what you would like to hear and see. Now it's about time for me to say goodbye. Thank you all for joining, for your answers and for your questions. It has been a great pleasure for me and everyone here in Hamburg. Thank you, dear partners, for coming to Hamburg and for such a great cooperation in preparing this event. Also, a big, big thank you to our colleagues here in Hamburg who made it work on the technical and the event organizational side, especially Johanna and David. Really, you did a great job. Thank you so much. And I sincerely hope we will see each other then at the physical event in 2021. Until then, please stay in touch, stay safe, and stay healthy. See you soon.